Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. In our last section, we actually looked at indices and how to apply the laws of indices. Now, today we are going to be looking at another very important topic, logarithm. Yes, logarithm. Now, the logarithm of a number, the logarithm of a number m to a given base, n can be defined as any power to which the base n can be raised to give the number m. Now, this is the definition of logarithm. The logarithm of a number m to a given base n can be defined as any power to which the base n can be raised to give the number m. Now, this is what we're saying. If you have log n base n, now if this is equal to x, it therefore means that n raised to the power of x, n power x must be equal to m. That's what we're saying. Now, the logarithm of this number m to a given base n can be defined as any power x to which n can be raised to give m. Now, let's look at some examples. E.g., now let's look at log 32 base 2. Now, 2 raised to the power of what will give 32. 2 raised to the power of 5 is 32 because 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 will give 32. So it means the answer here is 5. 2 power 5 is equal to 32. So that is the definition of logarithm. Now we're going to be looking at the laws of logarithm. Yes, laws of logarithm. Just like the case of indices, where we actually have the laws of indices, logarithm too, we also have laws that are actually guiding logarithm. Now, law number one, log m base m. Log m base m. Now, when the number and the base are equal, yeah, because this is log m base m, you have the value as 1. Because here, m raised to the power of 1 will give you m. Yes, m raised to the power of 1 is equal to m. And from the definition of logarithm, we said the logarithm of a number m to a given base n can be defined as any power to which the base n can be raised to give the value m. So it means here, m power 1 is m. So it means log m base m, this is m. Log m base m is equal to 1. So this is the first law of logarithm. Now what we're trying to say here, e.g., let's look at some examples. If you have log 20 base 20, the answer will give you 1. If you have log 10 base 10, the value will give 1. So log any number to the same base, where the number and the base are the same thing, the value will give 1. So that's law number 1. Now let's look at law number 2. Yes, law number 2. We have log m raised to the power of x base n. Yes, m raised to the power of x base n. Now, if you look at this law very well, you discover that it's the number that is actually carrying the power. Yes, it's the number that is actually carrying the power, not the base. So when the number is carrying the power, this is the same as saying x log m base n. Yes, x log m base n. Now what we're trying to say here is this. If you have log 2 raised to the power of 5 base 10, this is the same as saying 5 log 2 base 10. Yes. If you have log 4 raised to the power of 6 base 7, this is the same as saying 6 log 4 base 7. Yes, that's what we're trying to say. That's law number 2. When the number is actually carrying the power. Yes, the power falls back. Now, let's look at law number 3. Now, log m base n power x. Now, remember in law number 2, the number actually carried the power. Now, in this particular law now, is the base that is carrying the power. So, when the base is carrying the power, it means we have it as 1 all over x. Yes, 1 all over x log m base n. Now, example, e.g., example, if you have log 12 base 5 raised to the power of 2, this is the same as saying 1 all over 2 log 12 base 5. Yes. Now, let's do another example. Log 10 raised to the power of 2, yes, log 50 base 10 raised to the power of 2. This is the same as saying 1 all over 2 log 50 base 10. Yes, that's law number 3. When the base is carrying the power and the power is going back, it becomes 1, the reciprocal of the power, then log 50 base 10. Now, let's look at law number 4. Law number 4. Yes. Log m base n. Yes. Log m base n is the same as saying log m base x. That's any base at all. Divide by log n base x. Yes. This is called the change of base law. Yes, the change of base law. So it means if I have log 8 base 2, I can change this to log 8 base 10 divided by log 2 base 10. Yes, log 2 base 10 to any base. Yes, you can also call it log 8 base 50 divided by log 2 base 50 to any base. It is called change of base law. Now, let's see law number 5. Law number 5. Log n base n. This is the same as saying 1 all over. We have log n base m. Yes, that's the reciprocal. So what we're trying to say here is this. If you have log 2 base 10, or let's say log 10 base 2, this is the same as saying 1 all over log 2 base 10. Yes. If you have log 10 base 100, this is the same as saying 1 all over log 100 base 10. Yes, that's reciprocal. Now, let's look at law number 6. Law number 6. If you have log m times n base x, or let's call it base a this time. This is the same as saying log n base a plus log n base a. Yes, log m times n base a is same as log n base a plus log n base a. Now, this is what we're trying to see here. If you have log 2 times 10 base 5, this is the same as saying log 2 base 5 plus log 10 base 5. Another example, if you have log 4 times 20 base 7, this is the same as saying log 4 base 7 plus log 20 base 7. So all these are examples under the 6th law. Now let's see the 7th one. Now log to the same base a, let's see m divided by n. Yes, Yes, we have seen the multiplication law. Now let's see the division law. So here, this is the same as saying log m base a minus log n base a. Yes, log m divided by n to base a is log n base a minus log n base a. So here what we're trying to say is this. Let's look at this example. Log 30 divided by 7 base 5 is the same as saying log 30 base 5 minus log 7 base 5. That's the division law of logarithm. Now let's look at number 8. Let's look at number 8. Now let's look at m raised to the power of log x base m. Yes, m raised to the power of log x base m. So it means this is the same as saying x. Yes, the same as saying x. Yes, because since you have m here as the base, it means we have x left. Now what we're trying to say, 10 raised to the power of log 2 base 10. Yes, 10 raised to the power of log 2 base 10. The answer will just be 2. Yes, 10 raised to the power of log 2 base 10, the answer will be 2. Now, if you have 24 raised to the power of log 3 base 24, the answer will be 3. So that is what this law is saying. That m raised to the power of log x base m, that the value will give you this x. Yes, so if you have 5 raised to the power of log 10 base 5, because this base here and this base are equal, so the value here will give you 10. Yes, so these are the laws of logarithm. Now let's also see another very important value here under logarithm. Now when you have log 1 to any base, now remember in indices. In indices we said any number raised to the power of 0 is equal to 1. Yes, we said m raised to the power of 0 is equal to 1 in indices. So it means log 1 to base m must be equal to 0, because m raised to the power of 0 is 1. Yes, if any number raised to the power of 0 in indices is equal to 1, it means log 1 to any base is equal to 0. Yes, so these are the laws of logarithm. So we are going to be solving some questions based on the laws, those laws that we have actually covered. Yes, we're going to be solving some questions based on those laws that we have seen, the laws we have covered so far. Now, let me call it example 1. Example 1. Now, evaluate the following. Evaluate the following. Evaluate the following. A, we have log 8 base 2. B, we have log 2 base 8. C, we have log 243 base 3. D, we have log 3 base 243. E, we have log 625 base 5. F, we have log 5 base 625. G, we have 25 raised to the power of log 2 base 5. H, we have 100 raised to the power of log 3 base 10. Base 10. I, we have 10 raised to the power of log 9 base 100. J, we have log 243 base 3 plus, we have log 327 base 3, then we have minus log 81 base 3. Yes, now we are going to be looking at all these examples. Now this is power. Let me take it up. Log 9 base 100. Yes, it's power. Yeah, this is also power. Log 3 base 10. Let's take it up. It's power. Yeah, this is what we're saying here is log is 100 raised to the power of log 3 base 10. So we are going to be solving all these questions to mark logarithm. Yes, to show all the laws of how to apply the laws of logarithm. Now let's look at number 1, the A. Now we have log 8 base 2. Now remember from the laws of logarithm, we said when you have log m base n, the answer is 1. And when you have log m power x base n, it will be x log m base n. So in this case, this is the same as saying log 2 raised to the power of 3, then here we have base 2. Now because it's actually the number that is carrying the power, it becomes 3 log 2 base 2. And remember we said log m base n is 1. So it means log 2 base 2 is 1. So this should be 3 in bracket 1, and the answer will be 3. So it means log 8 base 2 is equal to 3. So that's A. Now let's quickly look at B now. Let's look at B. Now for question B, we have log 2 base 8. Log 2 base 8. Now this is the same as saying log 2 log m, then n power x is 1 all over x log m base n. It means in this case, what we have here will be, because it's the base that is carrying the power, it becomes 1 all over 3 log 2 base 2. So that will give us 1 all over 3 times 1. Because we said log m base n is 1. Since the number and the base are equal, it means we have 1. So 1 over 3 times 1 is 1 over 3. So it therefore means that log 2 base 8 is equal to 1 all over 3. So that's the answer. Now let's look at C and D. Now for C, we have log 243 base 3. Now this should be log, this 243 is 3 raised to the power of 5 base 3. Now the number is carrying the power, so this becomes 5 log 3 base 3. And that will give us 5 in bracket 1. So it means the whole of this now will be 5 times 1, which is 5. It therefore means that log 243 base 3, the answer is equal to 5. Yes. Now let's look at the D. We have log 3 base 243. So this will give us log 3 base 3 raised to the power of 5. Now looking at this is the base that is carrying the power. So this should be 1 all over 5. We have log 3 base 3. So that will give us 1 all over 5 in bracket 1, which is the same as 1 over 5. So it means log 3 base 243 is equal to 1 all over 5. Yes, 1 over 5. So I'm going to leave this one. Yes, let's start this. Now let's do a question G. Yes, let's do a question G. Now for question G, we have 25 raised to the power of log 2 base 5. Yes, and remember this law. We said m raised to the power of log x base m, that the value will be x. Yes, if those base here and the base here, they are equal, you just pick x. Yes, the value will be x. So now looking at this now, you will discover that here, those base and those base here, they are not equal. So we have to make those base to be the same, to have the same value with this. So this 25 is the same as 5 raised to the power of 2. And here we have log 2 base 5. Now, remember in this case, we said when you have log m power x base n, is the same thing as x log m base n. So it means this can be expressed in this form. So now I want to express 2 log 2 base 5 in this form. So it means I'll have 5 raised to the power of log. These 2 now will be 2 raised to the power of 2. Then here we have base 5, which is the same as saying 5 raised to the power of log 4 base 5. Now you can see here now that the base here and the base here, they are equal. So it means the value will just be equal to 4. So it means 25. Yes, it means 25 raised to the power of log 2 base 5. The answer is equal to 4. That's what we are saying. Now let's look at the next one. 100 raised to the power of log 3 base 10. Okay, 100 raised to the power. Okay, now let me start this also. Yes, let me start this. Now let's look at 10 raised to the power of log 9 base 100. Yes, 10 raised to the power of log 9 base 100. So here we have 10. Now that's question I. Yes, 10 raised to the power of log 9 base 100. Now looking at this is the same as saying 10 raised to the power of, we have log 9. The base here now is 10 raised to the power of 2. To make this base and this base the same thing. So here, now this will be equal to, now if you look at this now, remember this law. Here we said when you have log n power x. Now if the base is carrying the power, it becomes 1 all over x log n base n. So here is the base that is actually carrying the power. So it means it becomes 10 raised to the power of, it will be 1 all over 2 log 9 base 10. Yes. Now this is the same as now. Remember, this and this, they are not the same thing because now there's half here, 10 power half. So it means in this case, this will be the same as 10 raised to the power of, we have log 9 raised to the power of half. Yes, I'm bringing it to this other side. Now we have base 10. Now because the base here is 10 and here we have 10, so this becomes 9 raised to the power of half. And you know, from our laws of indices, one of the laws, we said any number raised to the power of half is the square root of that number. It means this is the same as saying the square root of 9, all raised to the power of 1. And that will give you 3 raised to the power of 1, which is equal to 3. It therefore means that 10 raised to the power of log 9 base 100, the answer is equal to 3. Yes, so that's question I. Now we're going to look at question J. Yes, question J. Now you can solve this question J in 2 forms. Yes, we can solve question J in 2 forms. Yes, we can apply 2 methods to analyze question J. Okay, now let's look at this now. Question J. Now J. We have log 243 base 3 plus log 27 base 3 minus log 81 base 3. Now solution. Now you can decide to solve each of these individually. Like for this one you have log, this 243 is 3 raised to the power of 5 base 3 plus, we have log 427 is 3 raised to the power of 3 base 3 minus, here we have log 81 is 3 raised to the power of 4 base 3. Now the powers will fall back. So here we have 5 log 3 base 3 plus 3 log 3 base 3 minus 4 log 3 base 3. And we all know that log 3 base 3 is 1. It means the whole of this now will be 5 in bracket 1 plus 3 in bracket 1 minus 4 in bracket 1. So here 5 times 1 is 5 plus 3 times 1 is 3 minus 4. And if you look at this very closely, 5 plus 3 is 8 and 8 minus 4 is 4. So it therefore means that the whole of this is equal to 4. Now let's see the second method. Now let me call this an alternative method. Alita, yes, that's alternatively. Now let's do it. Log 243 base 3 plus log 27 base 3 minus log 81 base 3. Yes, 81 base 3. Now applying the law. Yes, since all the bases are equal, look, let's look at it now. Here is base 3, here is base 3, and here is base 3. Yes, base 3, base 3. And remember we said for multiplication, that when you have a common base, log m base a plus log n base a is same as log a bracket n times n. So now this will be, this is the same as saying, now since we have a common log, common base rather, base 3, base 3, base 3, I'll pick log base 3. Now applying the law here, we have plus, so it becomes 243 times, here we have 27. Now we have minus, and we said when it is minus, you are dividing. When it is division, you are subtracting. So here, all over, here we have 81. Yes, all over 81. So it means the whole of this now will be equal to log, we have 3 here. 3 into this is 9. Yes, is 9. 3 into this is 27. Here we have 9 here is 1. 9 into 27 is 3. 3 here is 1. 3 into 243 is 81. Yes, it's 81. So here we have 81. Then here we have base 3. So it means the whole of this now, this is the same as saying log, this 81 is 3 raised to the power of 4. Yes, because we said 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 raised to the power of 4 is 81. So here we have base 3. So the whole of this now, 4 will fall back. So we have 4 log 3 base 3, which is the same thing as saying 4 times 1. And that will give us 4. So here we have seen that because here we have a common base, that is all the bases are equal, 3, 3, 3, we actually applied the law. But when the bases are not equal, you cannot apply this law. Yes, when the bases are not equal, you cannot apply this law. Instead, you solve them individually. You solve this on its own, and the other one on its own. So now, if you look at this, we actually solve question A, question B, question C, and question D. Now we left question E, question F, and question H. So I'm going to leave this for you to do as an assignment. So you can solve and drop your answer on the comment section. So thank you so much for listening. Watch out for more videos on logarithm. Share with your friend, subscribe, and God bless you. See you next time.